All right, guys, I'm gonna quickly here finish the rest of the notes from yesterday. So you did the assignment part of that worksheet. I want to say numbers 1 through 7, which was on just finding the area of a circle and then using those formulas with circumference, radius, diameter, and manipulating some stuff. This one, a sector, basically, it's a portion now of the circle's total area. So we talked about arc length a few weeks ago. That was a fraction of a circle's circumference. This is a portion of the total area. So imagine with pizza, this would be how big is your slice comparatively to the whole pizza, is essentially what a sector is. So the fancy definition there, it's a portion of a circle enclosed by 2 radii and the intercepted arc. And then I even put AKA area of a pizza slice. So down here, this is what you would see in the textbook if you happen to look at it. You don't have to, but basically it's just showing you the term in words, what it looks like in a picture, and then what the formula is. So what's the formula? It's very similar to what we use with length. You're gonna take the area, the measure of the arc. Let me grab a pen. In that case, AB, which is just the letters that they use in that particular example. So it's the arc over the total, just like before. Exactly the same. The degree over the total degrees, and then you multiply it. Now it's by the area formula. So before it was circumference, but now we're saying area. So you're gonna always use pi r squared, and you can go ahead and put that over 1 if you want. So here's an example that we would have just done as a class that wouldn't have been part of your notes necessarily, but find the exact area of the shaded region. So you would use 60 over 360 and then multiply it by pi r squared over 1. I reduced the 60 and 360 to 1/6. 4 squared becomes 16. And then when you multiply straight across, you'll get 16 pi over 6, which reduces by 2 to 8 pi over 3. That's the exact area of that red portion there. So these last 2 examples, I'll show you one at a time so you're fully watching it here. Let me zoom out a smidge. Okay. So on this one, the degree is 145, the radius is 10. So I just said 145 over 360 times pi r squared right there. So I reduced 145 and 360 to be 29 over 72. And then 10 squared gets me that 100. So this fraction times 100 gets me this. And then I reduce that to get this. That's the exact answer. And I went ahead and gave you the nearest 10th answer, which is right there. Please make sure you know how to type that accurately. Okay, so right now, test that with your push pause if you need to. And the last one right here. So this time I'm asking for that major arc. So you have to do 360 minus 75, and that's where I got the 285. So 285 right here over 360 times pi. The radius is 7 because it's half of the diameter. So 7 squared gets me this 49. I went ahead and reduced this first fraction to get me 57 over 72. I, in fact, actually didn't pick the highest GCF because it reduces again. So this actually becomes that, and then I multiplied straight across, and I got 931 over 24. That does not reduce any further. So that's my exact answer. And the nearest 10th answer is that 121.9. So now you should